Very good. So good afternoon, everyone, and welcome. So as I was just mentioning, this WebEx event is recorded and will be made available on the Sustainability intranet page in the coming days. So our Sustainability Lunch Talk series continues with this fourth edition, this time dedicated to climate change and its projected impacts on the Grand Duchy of Luxembourg. So I am Laurent Bétry. I am the Sustainability Officer at the University of Luxembourg, and I'm in charge of integrating sustainability into the operations and functionings of the university. And one of the facets of my action is to raise awareness of the university community in the various themes of sustainability. So this is why, together with the members of the Sustainability Coordination Expertise Group of the university, we have launched this series of discussion. So this series is for everyone, committed or not, because its main objective is to restore the facts in the mass of information that is about sustainability. This is why we invite recognized researchers in the field to inform us in a short interactive format on the contributions of science to the questions we wish to address. So today we propose to address a topic that is surely the most important and critical challenge facing humanity as a whole at the beginning of this century. Climate change and the limitation of temperature increase, according to the Paris Agreement, requires profound changes, both individual and societal. We talk a lot about mitigating climate change, but the great difficulties in changing our behaviors, consumption, mobility, food, also requires to take an urgent interest in adapting our societies to the new climate conditions, and this in all territories, including Luxembourg. To talk about this, we have invited Dr. Jürgen Jung, Group Leader of the Agro-Environmental Systems Group at the Luxembourg Institute of Science and Technology. His work focuses on the interactions between atmospheric processes and living organisms. And this webinar is co-hosted and moderated by Professor Alan Koff. He's a member of the Department of Geography and Social Planning in the Faculty of Humanities, Education and Social Sciences of the university. He holds the Gamma UL Chair in Regional Integration and Sustainability, and his work focuses on international development through the lens of policy coherence for sustainable development within the context of water politics, migration politics, and payments for ecological services. Alan, the floor is now yours.
Okay, thank you very much, Laurent. It's really a pleasure to be here today. I think this is a very important initiative to have these broader discussions on sustainability and fact-based discussions on sustainability. And in that regard, I think that we have a very interesting talk today given by Dr. Jürgen Jung, who, in addition to the information that you've already provided, has an interest in agricultural meteorology, climate change, and air quality. Now, for those of us in the social sciences, we don't think too much necessarily about meteorology, but I had the opportunity to be a discussant of a dissertation, a doctoral dissertation at the University of Helsinki in the field of political science. And it was very interesting to understand how much Finland, for example, is investing in meteorology projects related to development cooperation in the world because they recognize the importance of climate change and climate impacts. In fact, when we talk about climate change, we are profoundly talking about questions related to equality and inequality. And so in this regard, there really are very important policy lessons here. I mention this because Dr. Jung, in addition to an impressive list of scientific publications, also has a number of ongoing projects that are funded by ministries. And the current project is one called CHAPEL, High Resolution Climate Change Projections for the Greater Region, with which he works with the Ministry of Environment. I mention this because I think in addition to the scientific insights that we'll hear today, I think it's important to understand the social and the policy relevance of this talk. So without further ado, I will hand the floor over to Dr. Jung. Thank you very much, and I look forward to hearing the presentation.
Okay. Thanks a lot, Diana and Laurent. Thanks a lot for the kind introduction and also for the invitation and giving me the chance to present here some of our newest results and also to talk about climate change. Let's share my presentation. I hope you can see it. It's okay. Perfect. Okay, great. So, topic of today is a little bit on observations, because those observations can help us to come up with climate models. And I will try to highlight and explain to you how we can set up those climate models to project the future climate. We will start with a short introduction, a few words to the observations we are doing here in Luxembourg, and also how we can assess the future climate. Then we will have a look at the global scale and the impacts and projected impacts on the global scale for climate change, and then come back to Luxembourg with some examples from different sectors that might be of interest also from you. I think it's a fact that human activities have heated up our climate, and recent changes are more rapid and more intensive than those observed in the last centuries. And with each additional increment of warming, those changes will become larger, and resulting and long-lasting irreversible implications we have to face. What are the evidence of climate change? I've brought here a figure from the latest IPCC report. IPCC is the International Panel on Climate Change, and they published every couple of years a report containing all the knowledge of climatologists and other scientists on climate change. It's really very recommended to have a look at it, but to be also honest, it's more than 3,500 pages, so maybe just have a look at some of the chapters that might be interesting for you. If you're looking here at the different compartments of our climate system, air, ice, land, and ocean, what do we already see in the past? If you're talking about land surface temperature, I think heat waves are really an important topic. If we look just at the last summer here in Luxembourg, we had several heat waves, and it was not just here in Luxembourg. We also have so severe heat waves in Australia combined with fire events, and the same was valid for in North America and Florida and so on, and we have really severe impacts of those heat waves. Also, we have some other problems with storms, thunderstorms. Maybe you remember in 2019 we had the tornado here in Luxembourg with quite severe impacts and damages in the southern region. And just yesterday there was a notice in the newspaper that there was also a tornado yesterday evening in northern France. So those the frequency of those extreme events is starting to increase. Looking at some other impacts, if we are moving more to the ice, to the glaciers, what do we observe here? A global trend is that glaciers are going down. So the number of glaciers is reduced. So for example, for Germany, just this year, we lost one of our glaciers. We only have 4 remaining. So we lost the Southern Schneeferner glacier, which is not considered as long as a glacier. And this trend is really can be observed worldwide. Staying at the ice, we could also have a look at the Antarctic sea ice. By means of remote sensing, it's easily to quantify the extent, but also the thickness of the sea ice. And if you're looking at the annual spatial extent, we see a clear trend decrease, a lesser coverage of those sea ice. And staying at the oceans, we also have the sea level rise. And at the moment, more than 5 uninhabited islands disappeared already in the past decades due to sea level rise, and that will continue in the future. So is this area of Kiribati, north of New Zealand, with some small islands, and in the next decades, we will lose some of those islands due to the continuous rise in sea level change. Coming back to the land, I think some of you also remember the severe flooding in the Müllertal in 2080, and also here a picture from taken at Remich. It's quite common for those people that the roads near sides the Mosel are flooded quite frequently. So I think it's quite obvious that climate change is happening, not only on a global scale, but also already have arrived here in Luxembourg. Another figure taken from the IPCC report. What is important to highlight here, we have 2 different lines, one in blue that states the reconstructed global surface temperature, reconstructed from tree rings or ice rings, and so we can reconstruct the climate before the real measurement started around 1850. And what do we see? That there have always been variability in the future, in the past temperatures in the reconstructed ones. We see here the little ice age, but what is really important is that the speed of the warming really was never observed in such a high speed as in the last 17 years. A lot of people say, okay, climate was also variable with colder and hotter phase. And therefore, we printed here also the warmest period in the last 100,000 years. And okay, we are almost at the same level of warming, 1 degree above the average of that reference period. But for that warming, it was more than 6,000 or 7,000 years that it takes. But here, the warming in the last 70 years was really, really fast. And that is something where most of the target values we are looking at, like vegetation, pests, and animals, they are not able to adapt to that speed. If we are talking about climate change, we also have to deal with some definitions. I do not want to bother you with a lot of definitions, but something is important. It's about the difference between weather and climate. If you're talking about weather, it's quite simple. If you look just outside the window, you can see that it's raining, sun is shining, or whatever. We have a specific temperature and so on. That's the current state of the atmosphere. Climate is something different. It's something related to statistics. So it refers to the average weather condition at a dedicated place over many years, sorry. And if you're talking about many years, we normally refer to a 30-year period, a so-called reference period that is defined by the World Meteorological Organization. And I will come back to that during my talk quite often. So it's quite important so that we are aware that there's a difference between weather and really the climate. Let's now come to the observations and to how we can come up with those climate models that enables us to predict the future climate of our planet. Here we see a map of Luxembourg with all the meteorological and hydrological measurement stations. There are many actors active in that field, for example, the Agricultural Service, JASTA, the Water Agency, Findel Airport Station, also my institution runs several meteorological stations. So giving and considering the really small size of the country, we really have a very, very dense network of meteorological stations if you compare it to other countries like France, Belgium, or Germany. But we also have to state we have no official weather service in Luxembourg, and also we have a deficit in long-term climate measurements. I already stated if you're talking about climate, we need stations with measurements of more than 30 years. And here we have only a few stations that can deliver us those data. Therefore, I've chosen the Findel station at the Findel Airport. And what do we see here? The blue line are the annual average temperatures per year, starting roughly about 1945 and going up. It's still ongoing. That station is still measuring. What is important to note that we see here the gray dashed lines, and those are reference periods. The first one starting in 1961, lasting until 1990, and the second one is shifted to 1981, 2010. And if we take the average temperature here for the first reference period, we had an average temperature of 8.3 degrees, and in the second one here we have an average temperature of 9.3 degrees. So already in the past there was a temperature increase of 1 degree here in Luxembourg. We can now make a deeper analysis and look at the different meteorological seasons. I do not want to go in detail on that. Just as a take-home message, we see the warming in all of the seasons. It's most pronounced for the summer months, and all those differences are statistically significant. So there is a constant increase in temperature throughout the whole year. Now we could do those analyses for other meteorological values like precipitation, wind speed, humidity, and so on. I will skip that to some time constraints, just a few words on precipitation. Here the picture is also quite clear. We see a slight increase in the annual precipitation sums, but those increase is not evenly distributed through the year. So we have a clear trend towards wetter winters and drier summers, and also a trend towards more extreme events. coming back to the measurements at Findel. So based on those measurements, we can assess the climate of the past. But come on, we are interested in the future development. How will the climate looks like in Luxembourg in the next couple of decades? And here came so-called climate models into play. The basis for those climate models is the complex climate system, which all those compartments that are relevant for the climate. We have the forcing from the solar, from the sun as an input source. We have the contribution of humans by the emission of greenhouse gases, but also natural emissions caused by volcanic activities, and all the other compartments like the biosphere, hydrosphere, and so on. And what we are trying to do is to observe and measure all those interactions that are important for the climate system and try to apply that knowledge to create a computer model, a so-called climate model, global climate model of our planet. Then the modelers represent the Earth surface and the atmosphere as a virtual twin consisting of interactive three-dimensional boxes. And for each of those boxes, we can apply the mathematical equations that we obtain from our observations and describe those processes. And then we just have to transfer those equations into computer code that can be run on supercomputers, like, for example, the one here in Luxembourg, Meloxina, which was just come into force in this year. But then you can ask, okay, you come up with those nice models, but how can you be sure that those models are really reproducing the climate in a really good way? And also a second question, which is quite important, how can we be sure that humans are responsible for the fast increase during the last decades? And here again, a figure from the latest IPCC report where we see two different things. We see as black line the observed temperatures. Again, then starting of the observations. And what we see is if we just force our models with the natural forcing, so the solar and volcanic activity, we could reproduce the past climate quite well. At some point of time, there starts a difference, and that's where the really industrial revolution starts, and mankind starts to emit great amount of greenhouse gases into the atmosphere. And only if we add those greenhouse gases to the forcing of our models, we could really reproduce the strong increase of the surface temperature in the last decades. Another thing is that in climate science, we do not rely on just one single model realization. We always use a couple of models, the so-called multi-model approach, because there is no perfect model. Some of the models are better in doing climate simulations, for example, oceans or coastal areas. Some of them perform better for extreme events. So there is not one general model we can use. Therefore, we always use a couple of models and do, for example, a multi-model mean of the results. And the forcing is, besides the natural factors like solar radiation and volcanic activity, also the greenhouse gas emissions. For the past, it's quite easy because we can measure the greenhouse gases. So there were also quite long-term measurement time series of CO2 on a global scale. But the question is, what for the future? We also have to do some, have to get some data for the future. And here, those emission scenarios come into play. Those emission scenarios are a kind of storyline how mankind will develop in the future. For example, a very optimistic future, the so-called Paris Agreement, here shown as a blue line, dark blue line, so-called RCP 2.6, describes a world where we really try to protect our climate, reduce CO2 emissions, become carbon neutral, and do everything to reduce the impact of climate change and to mitigate it. But there are also other emission scenarios available, more pessimistic ones. For example, here, the RCP 8.5, and that describes a world where we do not really take care about our climate. We will continue to use fossil fuels, go by plane for 3 or 4 vacations per year, and do not care about our personal footprints. So those are different storylines how future may evolve, and based on this involvement, we can come up with related CO2 or general greenhouse gas emissions and use those emissions as a forcing for our climate models. Okay, let's have a look at the climate change at the global scale. Here a figure also from the IPCC, and it's targeting observed changes in hot extremes. Maybe some of you already noticed what we are seeing here is a map of the world. We have North and South America, Europe, Asia, Africa, and Australia. So, and what do we see here? If we concentrate on those three diamonds, we have here Northern Europe, Western Central Europe, and Eastern Europe. What we see is that for all three diamonds, we see an increase in those hot extremes, so heat waves or days with a temperature above a certain threshold. And what we also can see is that the confidence that humans are responsible for those changes is really high. We have the same figure here for heavy precipitation. Again, the picture overall is not so clear, but for those three triangles, we also see an increase in heavy precipitation events. But the confidence in the human contribution is not so high for Western and Eastern Europe. And last figure from that, it's concerning droughts, because lack of precipitation is really a severe problem. And what we see is that for Western and Central Europe, where also Luxembourg is located, we see a clear increase in those drought events, and that's something which matches very well the observations we did in the past year in Luxembourg. It's a more and more severe problem that we have a lack of precipitation during times that are especially important for the vegetation, in spring for the sowing and so on, and especially in the vegetation period, there's a lack of precipitation. Coming to the future for the global scale. On the left side, we see the different emission scenarios. The optimistic one, the Paris Agreement one, where we agreed to try to keep the global warming below 2 degrees, in an ideal world below 1.5 degrees, and also here the higher emission scenarios with more greenhouse gas emissions. I do not want to go into detail, just to some really short messages. If we look at the temperature changes, we see one thing, that we just only see red colors. So for the temperature, it's a clear signal. The whole world will heat up. It will be more pronounced on the surfaces, on the land surfaces, a little bit less on the oceans, because oceans can absorb more energy, and it's more pronounced for the northern hemisphere than the southern hemisphere. Looking at the precipitation, the picture is not so clear. We have here regions where we see a clear increase in precipitation, but also regions where there is a clear decline in precipitation. For example, the Mediterranean area, and that's really a hotspot for future drought events. So we see the picture is a little bit different, and what we have to really keep in mind, if we are talking about climate change, it's not only a constant rise of temperature, it's also affecting the other variables like precipitation, wind speed, radiation, and humidity, and so on. Let's come back to Luxembourg. What do we have to expect for Luxembourg? The good news is that we still have the choice. So there are two sides of the roads we can take. If we look at the optimistic way, so optimistic means we will follow the Paris Agreement and manage to keep our greenhouse gas emissions really low, then we see here projections for Luxembourg. As already stated, that are results from the Chapel project we are doing together with the Environmental Ministry. Climate change projections for Luxembourg, and see how climate change will really affect Luxembourg on a very, very local scale. And if we see here the results for the optimistic RCP 2.6, we see that we will have an increase in the air temperature from the reference period to the future period of roughly 1 degree, but we will manage to keep the temperature increase well below the target of 1.5 degree, and that's really good news. For precipitation, we will see a slight increase from 860 millimeters to 940, and then a small decline again until the end of the century. But again, everything is okay. If we really manage to follow the Paris Agreement and reduce our greenhouse gases, so I could stop my talk and say everything is okay, our problem is solved. But unfortunately, we also have the other side of the road, where the temperatures are going to rise more pronounced. We see an increase of 8 degrees until above 12 degrees until the end of the century, and that's a temperature increase by more than 3 degrees. And you have to keep in mind that we really are talking about annual mean temperatures. And I'm really not in favor of always doing this exercise to relocate Luxembourg to another place of the world where would it be when the temperature will increase, because we have not only temperature, we also have humidity, precipitation, and so on. But for that, we will have just looking at the air temperature, a climate that is related to Sicily. For precipitation, we will see a steady increase in precipitation until nearly 1,000 millimeters until the end of the century. And here we see a really very strong increase in the heavy precipitation events. And those heavy precipitation events will really have, in consequence, a higher amount of flooding. The water that will not be available for plants. It will be not available for groundwater recharge, and we will really run into severe problems of that. Now, looking at some impacts, I would like to start with the agricultural sector. So, of course, the increase in temperature has a direct influence of the growing season length of vegetation of plants. So that's the period where plants starts to grow depending on the temperature. And here again, some results for the optimistic RCP 2.6 scenario, and we can see that the vegetation period will be prolonged by roughly 20 days in the near and far future, which is an influence which the normal vegetation can cope with. If we are looking at the pessimistic scenario with a lot of greenhouse gas emissions, we will see a prolongation of the vegetation period for more than 60 days. And that is really will lead to a change in the species distribution of vegetation in our region. That brings me to another example from the agricultural side. Quite an old publication, but it's quite nice to demonstrate the influence on climate change on agricultural pests. We made an investigation on a common crop here in Luxembourg on oilseed. And there is also a common pest, the so-called cabbage stem weevil, which causes really large damages to that crop. And we did quite long-term observations, more than 50 years, where we do a monitoring of that pest species and combined with the meteorological measurements. And so we were able to come up with a model that describes the migration of that pest from its overwintering habitat to the fields of oilseed rape. And let's see for the past, let's have a look at the black curve. So normally those pests start the invasion from their overwintering habitats to the fields of oilseed rape around DOI 80, that's day of the year, and the peak invasion is around DOI 100. So that's something 10th of April or something. And then let's have a look, if we just look at the really far future, 2069 until end of the century, that's the red line. We can observe two different things. First, the peak invasion moves to an earlier onset in the year. It's around DOI 66. But the more important thing is for the farmer that the time span of the invasion becomes much, much longer. So, because in a practical way, the farmer has to do an observation of those pests and count the numbers of those weevils in their fields. And if a certain threshold number is broken, is waste, then they have to do some countermeasures like chemical applications or biopesticide, whatever. But for the farmer, it's important that in the future he has to start quite early in the year and he has to do those observations for a really long time. And for the farmer, time is money. So the costs for producing crops in the future may be rise based on those different time spans. Another example from the viticultural sector. Here we had to look at the number of frost days. And for the optimistic scenario, we will see a reduction in the number of frost days from average 72 days to 54 or 50 days in the future. So it's not so much. But looking at the other emission scenario, we really see a reduction of down to 23 days. And so you could say, okay, that's totally fine, because then the frost risk will be lower in the future. But you have to keep in mind that a lower number of frost days not automatically means a reduction in the frost risk for viticulture, for example, because we have to take into account in parallel the influence of the temperature to the vegetation. And therefore, we also did a model based on our observations of the bud burst of viticulture, and here is it for Riesling. And what do we see? The bud burst for Riesling takes place normally around DOI 100. And if we look at the evolution of those, we see that there is a slight trend towards an earlier onset. But what is more important is that if we look in parallel at the days of the latest frost, then we see a more pronounced trend. So we can summarize that the risk for frost is decreasing in the future, but due to the higher variability, there will still be a risk of late frost events, even under a quite high warming scenario in the far future. At the moment, we are doing that exercise to check what about the production of ice wine here in Luxembourg. And to be honest, I would not be so optimistic for ice wine. It's a different picture, so I would not bet on a big ice wine production anymore in the next decades here in Luxembourg. That brings me to one of my last examples, heat waves and urban heat islands. So cities are really the future hotspots for heat waves. And you know that there's a global trend that in the future more and more people are moving towards the cities, and more than 50% of the world's population will live in cities in the next decades. So what we did a study on the evolution of those heat stress and thermal stress in 3 different European capitals, London, Rome, and Luxembourg. And at first, we just looked at the number of heat waves per year. We again compared the number to a reference time span, here 1971 to 2000. And if we check just the far future, 2061 to 2090, we see that there's a constant increase in those number of heat waves. So on average, all 3 cities will be roughly, there will be a roughly increase in 4 up to 5 more heat waves per year. Then if we look at the intensity of the heat waves, so intensity is here defined as the average temperature of all heat waves per year, we see a little bit different picture because Luxembourg is affected much more than Rome and London. And if we really have an increase, which is roughly about 5 degrees in the heat wave intensity, the thermal stress levels in the inner city centers will really become dramatic. Therefore, at the moment, we are doing some studies on that. Last year, we did a countrywide biometeorological assessment, also with numerical models for the thermal stress in Luxembourg. And here's an example of those modeling results for the area of Esch and Bellewalle and Bellevaux. What we see from yellow to orange and red and even purple, those are the areas with higher thermal stress levels. What we also have to take into account that we have those green areas where during night times cold air production is starting. So those areas produce cold and fresh air. And if we have some so-called corridors that connect the cold air production areas with the inner city centers, then the inner city centers can be cooled down. And therefore, it is important for us to know, on the one hand, where those cold air production areas are and how much cold air they can produce. And also to keep those corridors that brings the cold air into the city centers alive and do not block them with additional constructions. And that's something we are currently investigating for the Prosud region at a higher spatial scale. Also important is the implementation of green and blue infrastructure. That's quite simple. With blue infrastructure refers to open water sources. Green infrastructure is the vegetation, and vegetation is always beneficial for the inner cities because on the one hand it helps to cool down the cities via evapotranspiration, but has also additional positive effects like filtering different air pollutants or shading effects for the people. So that's something we are currently also investigating. And with those examples, I just want to conclude my talk. The good news is that, as I said, we still have the choice which side of the road we would like to take, but all of us must contribute to this big challenge, and we have to reduce our individual CO2 carbon footprint substantially to contribute to the Paris Agreement and also to the UN Sustainable Development Goals. We still have some time, but no time to be inactive. With that, I thank you for listening, and I will be happy to answer your questions and hand over again to Harlem.
Thank you very much, Jürgen, for that very insightful presentation. And so we're going to begin the discussion in one moment. I would just ask everybody a little patience because there are two very brief points that I would like to make, and I'm going to show quickly a few slides from some of my own work. Because when we talk about climate change, one of the things that is often discussed is the need for systemic change. You know, oftentimes whenever we're discussing the threats that climate change are actually posing, a number of leading figures are calling it civilizational in terms of threats, that we really need transformative change in this world. And the question is, what does transformative change mean? Now, Laurent at the beginning mentioned that I study policy coherence for sustainable development, and that is a tool which is developed by international organizations to create a whole of government approach to addressing these types of issues related to sustainability and climate. Now, when we talk about this, however, the problem with policy coherence for sustainable development, in my opinion, is that it's highly institutionalized. And we look at policy as a product of government, and there's really no focus on communities or public opinion. And so, for example, when we talk about a whole of government approach, one of the things that I think is very interesting, when we take, this is just some scaling that I've done with my own research looking at policies. And, you know, a -3 would show that policies are actually canceling our objectives related to, for example, climate action. A +3 would show that there's an interaction which is positive and cooperative, and then the others are mixed. But the point I want to show here is when you take a look at different policy sectors like industrialization, transportation, energy, agriculture, climate finance, policies actually in a number of fields are actually cooperating with the objective of climate mitigation or climate action. However, we have a negative score under industrialization policies. And this is actually where I think we need to have this big discussion on climate action. Right now, we're about to hold the meeting for COP27, you know, the Conference of Parties organized by the UN in Egypt at the end of this month. And there's going to be a strong focus on climate finance, but also on climate economics. And I think that this needs to be central in terms of our discussions. Because if you take a look at the countries and how they score in this, and we don't need to get into the details, but just to show you briefly, the negative scores come from Czech Republic and Poland. These are countries that obviously lag economically compared to the other countries in Western Europe. And also in terms of public opinion, what we're seeing here, for example, in terms of policy coherence for development and climate change, is that there's really no trends in terms of public opinion in Europe. We actually see in terms of concern over climate change, Sweden and Poland, which have very similar scores, even though in terms of policy, Sweden is one of the leaders of climate policy in Europe, and Poland is one of the countries that scores negatively. So one of the difficulties that I want to highlight here is there seems to be a disconnect between policy and public opinion. We haven't yet created this bridge between citizen participation and climate action and climate policy. And then the second thing, which I think is very difficult, is this question of path dependency. Even though countries in Europe, because of European Union action and climate policy, are focused on climate action, nonetheless, the economic models which drive different countries are actually driving, if you will, their industrialization and their economic policies, which are undermining our climate goals. And I think that this complements a bit the discussion that we've just had, because this conversation actually, Dr. Jung is showing clear impacts in terms of data at the local level. And this data, I think, is very important because it actually seems to be reflecting threats that come more from economic policy and less from actually our climate policies. So with that, I'm going to stop sharing briefly. And I want to link this, Dr. Jung, to the first questions that we've had. When I talk about economic models, there are a number of questions in the chat focusing on Luxembourg. And this question of Luxembourg as a small country and what can it actually do, Luxembourg being dependent on energy from countries across the border, then the issue of fossil fuel emissions and all of the traffic and the cars that we have in Luxembourg. I think this is a very important question for a small state, not just Luxembourg. I would just like to add that in terms of the Sustainable Development Index, which is a UN index related to sustainable impacts of the different countries that are measured in the impact for spillover, which means negative impacts across the border, the 5 last countries in that index are all small states, and Luxembourg scores 3rd to last in that index, which means it has a net negative score of spillover. So how can we focus on Luxembourg as a small state? How do you view it in terms of climate impacts? Is it receiving impacts from across the border, or is it more sending its impacts across the border?
Yeah, so I would say we know that there are always those problems. If you go down to statistic of those small countries, you will also have some effects that the statistics not really represent the real life. But what we have to state is that for sure, even ignoring the traffic sector, Luxembourg is consuming far too much CO2. If we convert our consumption to CO2. And that's something we really have to change. We have to change it on an individual basis, because you can state that, come on, these couple of 1,000 tons reductions that Luxembourg can contribute to the worldwide emissions, it will change climate change. But I think it's important that everybody in the world contributes to that change of our mindset. And also from another positive side, if we really come up with, based on our technical knowledge and also the economic power that Luxembourg has, to come up with new adaptation strategies. Those adaptation strategies can be easily exported to other countries, and so Luxembourg can take over the lead for being carbon neutral, and we are really on a good way. If you're looking at the emissions by traffic, despite also the effect of COVID, in the last years, there was a substantial reduction in the traffic emissions. We just have to really check it, how much was related to COVID. But I think at the moment, the commuter numbers are going down due to the more attractive teleworking and so on. So I think, and also giving the public transportation, which is now for free. So I think Luxembourg is quite on a good way to that.
Okay, thank you. And then another question which came up in different comments asks, how can we take data on local impacts and utilize it to influence these more global discussions?
Yeah, I think it's, okay, at the moment, we are really not the hotspot area of those impacts. We can notice them, we can measure them, and we see changes in the vegetation, we see changes in the intensity of extreme events. But I think it's important that we should also try to support, of course, all the other countries which are really more affected by climate change at the moment. I've shown you some results for the projections for the Mediterranean area. And so in a couple of decades, for example, in Italy, we will really have really problems with vegetation, and the people are not able to live anymore in those cities. And so I think what we can do is really to come up with solutions and transfer them to those other countries.
Okay, thank you. Now, in terms of, I'm sorry, forgive me, continue.
No, it's fine.
Okay. You made you had a statement which I'm sorry just jumped out at me. I tend not to do this when I moderate, but it really was an impressive statement for someone interested in policy. You said there's no perfect model. And I'd like to know, how does this impact the effects of science on these bigger discussions with climate change? Does the fact that no perfect model exists undermine the impact of science in the global arena?
Yeah, I think it's really it's an important point, because no, we clearly have to admit that all those models that we create are not perfect models. We always have to communicate the uncertainties that are related to our projections. There are different approaches available in the scientific community. As I stated, we use multi-model means, then we do a bias correction of the output. So just to be sure that our observations match with the model results. But I think it's really important that we really say, okay, we have some avenues, we can show you how those variables will develop in the future, but we also have to clearly communicate what is possible and what is not possible. For example, we were always asked by, for example, a couple of weeks ago, by a company which is setting up windmills in Luxembourg and wants to have, okay, what will be the impact of climate change on those windmills in the future? And we must say, okay, sorry, we cannot tell you that. At the moment, the spatial resolution of our models is not high enough, and we can give you not really a clear answer. So I think what is really most important, and what a couple of scientists did in the best way in the past, that we really also communicate the uncertainties and clearly state, okay, at one moment, stop, that is something which is uncertain and we cannot give you a clear answer. Because if you do not do that, you will not be reliable and you lose trust of the people.
Okay, thank you. Now, you have some questions related to the science itself. Now, I mentioned earlier this whole of government approach and the need for us to look at climate change through different policy sectors. But you have a question asking if this data, for example, is used for decision or for studies in other sectors, for example, public health, and how this data is related to issues that affect heat exposure, floods, or waterborne diseases.
Yes, so a couple of years ago, for 3 years, we were involved in the setup of the adaptation strategy to climate change for Luxembourg. It was quite a really nice exercise, because we did, together with the environmental ministry and other ministries, a risk assessment for different sectors. I think 9 or 10 sectors were identified. Health sector, energy sector, of course, also agriculture and so on. And then we did a risk assessment and check how big the impact of climate change will be and how important, from an economic point of view, the impact will affect Luxembourg. Unfortunately, for this study, we had to rely on old, outdated emission scenarios, because also the behavior of the mankind has changed in the last decades. And based on that, we are now happy to come up with an update of that adaptation strategy based on the results of the Chapel project, where we really use new emission scenarios and can really do have a more clear picture about the impact really on a local scale, because we also increased the spatial resolution of the models. In the last study, we had just 1 point for Luxembourg, because the spatial resolution of the model was 20 kilometers or something, and you not only take one model point, you always have a box of three boxes, and so you have just 1 point for Luxembourg. And now with the new results, which will hopefully be ready in 1 year, we will have a spatial resolution of 3 kilometers, so that we really can make different analysis for different regions of Luxembourg, for example, for the Mosel Valley or for the northern part of Luxembourg. And so what I can clearly state that those data are used by the different ministries, and they were used for the different adaptation and mitigation strategies. Because if we are talking about mitigation, some strategies are really for the long term. If we are doing, for example, some countermeasures for floods, those countermeasures must be valid for the next 20 or 30 years. And so those data are very useful and of quite a high value for the local adaptation strategy of Luxembourg.
Okay, thank you. And also thank you for discussing the scale of data, because you've already answered another question that was in the, in the chat. Two more questions related to the data. How can the multi-mode approach account for tipping points? And how confident are you in the projected increase in precipitation for Luxembourg?
Okay, so as those models rely really on the physical properties, we are not talking about statistical models, they are really physical models that try to do it as good as they can to reproduce the behavior of the atmosphere. Also, the tipping points are taken into account. And what we clearly see is also in the global models that there will be a reduction in some ocean bigger ocean streams. We see the higher emissions of the of methane emissions due to the defreezing of the Antarctic soils. So those tipping points are taken into account. For the second questions, what I must admit is that the projections of temperature is much more easier than those of precipitation. You also have seen for the past observations that the results for precipitation are not so clear as for the temperatures. But what we can see is that in the last decade, our observations here in Luxembourg match quite well with our projections. So we see the increase in drought events, we see the increase in the lack of recharge of the groundwater. So I am quite confident in the quality of the projections in precipitation. Another little bit more critical point is if we are talking about extreme events, heavy precipitation events, and so on. Hence, those events appear not so often in the past. We have not really reliable data sets on that. So we see on a global scale the increase of those extreme events, but to come up with sound projections for Luxembourg, it's really difficult, and I would not rely on global models for that. We really have to do those downscaling with regional climate models to come up with spatial resolutions going below 3 kilometers, where we really can model those heavy precipitation events. So.
Okay, thank you. So we've discussed space. The other question here is related to time. You have the question, how do you manage time, especially reconciling the long-term and short-term time frames?
Yes, so first of all, what we can say is even if we would stop our greenhouse gas emissions by tomorrow and cut them down to zero, due to the lifetime of those greenhouse gases, we will see a continuous rise in temperature and changes in precipitation events until the mid of the century. And you also may have noticed, maybe from other talks and figures, that the differences between the temperature increase of the different emission scenarios until the mid of this century is not so high. It really starts becoming extreme if you're looking at the second half of the century. So what we are doing at the moment, those models are giving us quite high resolution data. They are calculating with time steps of seconds, but due to some constraints, we just store the hourly values and daily values so that we can have really transient projections of the future climate until the end of the century. And then we can do the analysis of the data. And so we really have a quite clear picture about the evolution of those meteorological factors over time. That helps to answer the question.
Okay, thank you very much. Now, I was also struck, you talk about cities being the center for heat in the future. And when we talk about Luxembourg and we think of policies, we often think, for example, of the free transportation, climate finance, things that Luxembourg is committed to. Yet at the same time, when we look at the greater region, what you see is just rapid urbanization. And so I was wondering if you could maybe discuss this, the impact of urbanization in your opinion in the greater region and its impacts on climate change.
Of course. So what we have seen in the last decades that really Luxembourg is growing and growing, and each day there are new constructions, and I think it's also important for the economic state of Luxembourg that there is amount of growth. I think that's also important to state. But what we have to keep in mind that if we are doing urban planning, we have to take into account those thermal stress and those climate impacts. To be honest, we are sitting here near Belval, and from my point of view, it's really one of the baddest examples of urban construction. You have a totally sealed surface, almost no vegetation, and so on. So if you would look in an exercise book for climate change, it would be one of, or it could be used as a really bad example. So if we are really doing future planning of cities, also taking into account nature-based solutions, as I mentioned, benefit from additional vegetation, let it be inner urban parks, let it be green roofs or whatever, it can really help to improve the air quality and also thermal stress levels. And even if we have a constant growth and additional people moving to Luxembourg, we can manage to reduce the thermal stress levels within cities really quite decently. That has been shown in different countries and different bigger cities. It's just a matter of a decent planning and the willingness to support that green infrastructure.
Okay, thank you. I'm glad the University of Luxembourg Sustainability Officer is here to hear your answer. I'll and potentially take note for future discussions. Okay, we only have a minute left, so I'm going to link two questions, if I may. The first one actually is a comment in the chat. It says when we discuss 1.5% degrees Celsius or 2 degrees Celsius, this actually sounds harmless in public debates. And if you have a short way to describe what that really means. And then we had another question which actually asked, how is it that your data can be linked to the extreme events, that you describe? And I think that this really does, both of these comments relate to the questions of, what we know in terms of climate science, and then what we're seeing in terms of events and the confusion in public debates between the links between the two.
Okay, for the first question, I think it's really important that we really be aware that we are talking about annual mean values, and the shift in annual mean value is really something big, because if I don't like those examples, if you're shifting geolocations and compare where a city will be or how the city will be like in a couple of years. But for example, Paris climate will be like Canberra's climate in Australia in 2050. And the really problem is that the people, they do not adapt to the changes in the mean values. We have to adapt to the changes in the extreme values, because an increase of 1 degree on a daily average, nobody cares. But as I showed you, an increase of 5 degrees in a heat wave, it has a tremendous impact on human health. And we have seen the losses in lifetime, and also the additional people who died during the big heat waves in Europe in 2003 and 2030. And those heat waves that we will face if we really do not manage to keep the warming below 1.5 or 2 degrees, it will really have an impact also here in Luxembourg. And that's something we really have to take into account. Addressing the extreme events, as I said, now with the help of better modeling approaches, as we are now doing in cooperation with the Environmental Ministry, if we really go down to a spatial resolution below 3 kilometers for those climate modelings, then we also can better address those extreme events. Because if you are modeling the climate on a global scale, some precipitation events are more we do a parameterization, because the events of a small thunderstorm as a small thunderstorm is too small from the area that it covers to be addressed on such a grid cell of 20 kilometers. But if you go down, for example, to a lower spatial resolution, below 3 kilometers, then we are also able to model, for example, thunderstorms, or those precipitation events that will lead to heavy flooding. And so I'm quite confident with the improvement of the models, and also due to the better computational power, we will also be better able to address those extreme events in the frequency.
Okay, well, thank you very much. We're getting some more very interesting comments and questions in the chat. My apologies to people as we are at the end of our time. Anyway, if you have questions, I think you can reach out to Jürgen Junk in the future.
Yeah, of course, no problem. Would be welcome.
Wonderful. So thank you very much, Jürgen. A round of applause, I think, is well deserved today. With that, I would like to hand the floor back over to Laurent.
Okay, thank you very much. Thank you, Jürgen and Harlan, for this very interesting webinar. I'm also very much interested in your comment regarding the area of green that we lack in Belval campus, and that was very interesting because we see the connection with a recent discussion that we had about Belval and the future of Belval that FHAC organized recently. So clearly, well, the same questions arise still and still. I hope that you enjoyed the presentation and the Q&A session. The recording of the talk will be made available on the Sustainability intranet page in a few days. It's now time to end the talk, and I would like to invite you already for the fifth Sustainability talk. Yes, already the fifth one that is scheduled on Wednesday, the 7th of December. It will be about solar cells. So I wish you a very good afternoon, and I'm closing the talk by thanking again Dr. Jürgen Junk and Professor Harlan Kopp for their excellent contributions. And I wish you a very pleasant afternoon, a sunny one apparently, and goodbye.
Thanks a lot. Bye.
Bye.